First MCQ is, during chemical analysis of a compound containing carbon, hydrogen and oxygen, water produced is absorbed by. So water is absorbed by magnesium perchlorate. An unknown compound was analyzed. The result revealed that it contained 80% carbon and 20% hydrogen. On the basis of available data, empirical formula of the compound must be. So the empirical formula is CH3. So here we know that carbon is 80% and hydrogen is 20%. Okay, so first of all you have to find the mole ratio. Okay, for mole ratio, divide the percentage of the elements. Take the percentage of the element and divide it by the atomic mass of the element. Okay, so for carbon it's 12 and for hydrogen it's 1. Okay, so when you divide these two you will get 6.66 and here you will get 20. Okay, now take the smallest one and divide it by both. Okay, so take this 6.66 and divide it by 6.66 also. Okay, and take this one and divide 20 by 6.66. Okay, so here you will get 1 and here you will get 3.003. so the ratio of carbon is, the empirical formula is C1H3, so it means CH3. Okay, so here option B is the correct one. All of the following compounds can be analyzed by combustion analysis except. So the except one is hydrogen peroxide because this one is inorganic. Okay, and combustion analysis is for organic compounds. A sample of an ionic compound contained 2.82 gram of sodium, 4.35 gram of chlorine and 7.83 gram oxygen. The empirical formula for this compound is. Now you have to find the mole ratio also here. Okay, take this 8.82 and divide it by 23 atomic mass of sodium, 4.35 divided by 35.5 atomic mass of chlorine and 7.83 divided by 16 atomic mass of oxygen. Okay, now simply just round off these number. Okay, so you will get 3, 4 and 8. Okay, now by dividing these two you will get 0.13, 0.11. okay, and this one you will get 0.5. now take the smallest one and divide all the numbers by this one. Okay, like this 0.11, so you will get 1.11 and 4.5, or simply you can write it by like 1 ratio 1 into 4. Okay, so you will get this number, which means that the empirical formula is NaClO4. Okay, so here option D is the correct one. Okay, NaClO4. A compound contains 6 atoms of carbon per molecule. The percentage of carbon in this compound is 40%. The molecular mass of the compound will be. Now this is the formula: percentage composition is equal to total mass of carbon divided by molecular mass multiplied by 100%. Okay, so the compound contains 6 atoms of carbon per molecule. Okay, so we will write 6 multiplied by 12. Okay, which is equal to 72. So total mass of the carbon is 72. Okay, and the molecular mass, take this molecular mass here. Okay, and bring the percentage here on division side. Okay, so you will get the molecular mass is equal to 72, percentage is 40. Okay, and multiply by 100. So here, and 4 1s are 4, so here you will get 4 1s are 4. Okay, and 3, so 4 8s are 32, 4 18s are 72 you will get. Okay, and multiply by 10, so you will get 180. Molecular mass of the compound is 180. Which of the following element present in the compound cannot be determined by the combustion analysis? So oxygen, hydrogen and carbon, these three can be analyzed during combustion analysis. Okay, so option D is the correct one. A compound contains 10% phosphorus. If atomic mass of phosphorus is 31, the molecular mass of the compound having 1 phosphorus atom per molecule. So the molecular mass is equal to total mass of the atom, and total mass is 31 atomic mass multiplied by number of atoms. Okay, so number of atoms per molecule is 1, and it is divided by percentage, which is 10. Okay, and multiplied by 100%. so you will get, this one will cancel this one, okay, 310. So option A is the correct. Which one of the following is the quantitative chemical analysis? So look at here, titration is the quantitative analysis, and these three, this one, and this one, they are the qualitative analysis. C2H6O is the molecular formula of ethanol, methanol, dimethyl ether and diethyl ether. So this, it's very simple. Look at here, this there is 2 carbon atoms, so it means that these 2 is incorrect, okay, this one, because methanol has 1 carbon. And look at here, diethyl ether, this one is also incorrect because this one contained the 4 carbon atoms, so for this one is also incorrect. Now we have to see whether it is ethanol or dimethyl ether. Now look at here, the formula for ethanol is C2H5OH, and the formula for dimethyl ether is CH3O and CH3. So 1 2, okay, and 1 2. And look at here, hydrogen is 6, so 5 6 and 3 3 6, and oxygen is 1, so it means that 1 and 3 is the correct one, okay. Look at here, 1 and 3. Which of the following technique is used for determination of functional group in a compound? So for determination of functional group we use infrared spectroscopy, because there is a special region for the functional group analysis, okay. In infrared spectroscopy there is a special region for functional group analysis. 2 different compounds will give different absorption peak in dash region. Option A. Ultraviolet ranges from A 200 nanometer to 400 nanometer. And look at the 17. Which one of the following hydrocarbon produces an NMR spectrum with more than 1 peak? So for finding the peaks in NMR spectrum there is a simple trick, okay. Look at here, in option A methane is given, okay. Now the trick is that if I want to change this hydrogen and replace it with chlorine, okay, let's suppose I replace this hydrogen with chlorine, okay. Now just name this one, okay. If I want to name this one will get chloromethane name, okay. So now instead of changing this one, let's suppose I replace this hydrogen with chlorine, so this one, it will also get the chloromethane, the same as this one. So if I want to replace this chlorine, okay, instead of this one, again it will get the chloromethane as name, okay, the same. Now if I want to replace this one, again this compound will get the chloromethane. So this is a simple trick, okay, for finding the peaks. So this compound, when we change any of the hydrogen, okay, so the name is the same, okay, for all the hydrogen. So it means that this compound will give only 1 peak in NMR spectrum, okay, because the name is the same for all the hydrogen. Now let's suppose ethane is there, okay. Now change this hydrogen with chlorine, okay, replace this one with chlorine, so you will get 1 chloroethane, okay. Now let's suppose I replace this one, so this one will get 1 chloroethane, okay. And now by replacing this one instead of this, the compound also get the name same, okay, 1 chloroethane. Now let's see this one, replace this with chlorine, so again this compound will get 1 chloroethane name, okay, because here we will start the numbering from this carbon, okay. So again it will get the same name as 1 chloroethane. Now let's replace this chlorine, okay, so again it will get 1 chloroethane as name. Now let's replace this 1 chlorine, so again this compound will get 1 chloroethane. So the name is same for all the hydrogen. If we replace any of hydrogen in for this compound, so we will get the same name. So it means that this compound will get only 1 peak in NMR spectrum. And it also indicates that all the hydrogen atom has the same environment, okay, so that's why it will get only 1 peak. Now let's consider this butane, okay. If I want to replace this hydrogen, okay, with chlorine, so this compound will get the name as 1-chlorobutane, okay. And for replacing this one, it will also get 1-chlorobutane, and by replacing this one hydrogen, it will also get the 1-chlorobutane as name, okay. Now let's see this one. When we replace this hydrogen, so with chlorine, okay, so this compound will get the 2-chlorobutane as name, okay. And also by replacing this one, it will also get the name of 2-chlorobutane. So it means that these two are different from each other, okay, this one and this one. So these three are same, okay, so they will get A and A, okay. One peak is there, and these two are the same, so it will get BB. But the A and B they have the different environment, okay, so that's why A and B will be here for different name, okay, so they will get the different peak. Now look at here, if I want to replace this one, so you will get 1-chlorobutane, okay. And if I want to replace this one, you will also get the 1-chlorobutane, and by replacing this one, the name will be the same, 1-chlorobutane. So it means that these two have the same environment, okay. These three hydrogen and these three hydrogen has the same environment, so A and A, okay. Now if I want to replace this hydrogen, okay, these two, so you will get the 2-chlorobutane, okay. So it means that the environment of this hydrogen, these two hydrogen and these two hydrogen same. That's why when we replace any of them, they will get the same name, okay. This compound will get the same name, so name it B and B. Now this indicates that this compound in NMR spectrum will get the 2 peaks, okay, 2 peaks. Now look at here, cyclobutane. Now if I want to replace this hydrogen, so it will get the 1-chlorocyclobutane as name, okay, and the same will be here, 1-chlorobutane. Now if I want to replace this one, okay, instead of this, so again it will get 1-chlorocyclobutane as their name. Now if I want to replace this hydrogen, so with chlorine, okay, instead of this one, so the compound will get 1-chlorobutane as name. If I want to replace this hydrogen, the compound will get the same name, 1-chlorobutane. So it means that the environment of these hydrogen is same, okay, so it will get 1 peak in NMR spectrum. So this one will get 1 peak, this butane will get 2 peaks in NMR spectrum, and ethane will get the 1 peak, okay, in NMR spectrum, and methane will also get the 1 peak. So look at them. Which one of the following hydrocarbon produce an NMR spectrum with more than 1 peak? So butane. For the compound CHCl2 and CH2Cl, how many single peak would you expect it in NMR spectrum? So it will get 2 peaks, okay. How many types of NMR spectra are there in the following compound? So the peaks will be 4 here, okay. Like the one will be this one, A, okay. Now look at here, when we replace any of hydrogen here, so it will get the different name, so name it B, and here name this one as C, okay, and this one will get the name of D. So by replacing any of hydrogen in this compound, you will get the different name, okay. So that's why that is a short trick for finding the peaks, okay. So you will get the 4 peaks in this compound. Which of the following transition is the highest energy transition? So sigma to sigma star is the highest energy transition, because the sigma electron are of high energy, okay, that's why its transition is the highest energy transition. The correct order for the basic features of mass spectrometer is, so first we do ionization, then acceleration, then deflection and detection. So option B is correct here. Which one of the following statement about ionization in a mass spectrometer is incorrect? So option A here is gaseous atoms are ionized by bombarding them with high energy electron. This one is the correct statement, okay. Look at the B. Atoms are ionized so that they can be accelerated. This one is also correct. Atoms are ionized so that they can be deflected, okay. This one is also the correct one. The D is, it doesn't matter how much energy you use to ionize the atom. So this one is the incorrect, okay. because you have to use the specific amount of energy for the ionization of atom. The path of ion after deflection depend upon both charge and mass of the ion. Option C is the correct. Okay. Which of the following pieces of information cannot be obtained from an infrared spectrum? So option A is the molecular mass, option B is the presence of carbon-oxygen double bond, option C is the presence of OH bond, and D is identity of a compound through comparison with other spectra. So here option A is the correct one, because we cannot obtain the molecular mass of compound. The molecular mass is obtained by mass spectrometry. Okay, and here we obtain the functional group, okay, in infrared, and also the identity can be obtained by infrared spectrum. Proton NMR is used for investigating the structure of organic compound, because so here option C is the correct. Okay, hydrogen atoms are found nearly in all the organic compound. That's why we use the proton NMR in investigating the structure of organic compound. Here proton refers to the hydrogen atom. Okay, which of the following statement about the trimethyl silicane is incorrect? So A is it produces a single peak at sigma is equal to 10. So this one is incorrect. Okay, because when sigma is equal to 0, so it produces a single peak. Okay, so option A is the incorrect one. Signals in a proton NMR spectrum do not provide information about. Option A is the relative number of hydrogen atom in a particular environment, the number of chemically different hydrogen atom on adjacent atom, the environment of different hydrogen atom in a molecule. The D is the molecular mass of the organic molecule. So option D is the incorrect one. Okay, because the molecular mass of organic compound is obtained only by mass spectrometer. Okay, and these three information can be obtained by using a proton NMR spectrum. So option D is the correct one. But it is incorrect about the NMR spectrum. Okay, to work out the molecular mass of an organic molecule, you would look at its mass spectrum. Okay, option B. Which of the following method would be the best for finding the identity of an organic compound? So infrared spectrum is the best method. Okay, option C is the correct here. Look, this one is used for the molecular mass. Okay, and NMR is used for finding the environment of the proton. Okay, for different proton. Okay, so option C is used for the identity of organic compound. What does the notation N2 sigma star means? So it means that the absorption, okay, like the transition from non-bonding molecular orbital to sigma star bonding molecular orbital. Like the electron absorb the energy and it transmit from the non-bonding molecular orbital to sigma star bonding molecular orbital. Bromine possesses two isotopes, 79 and 81, in an approximate 1:1. In the mass spectrum of bromine, how many peaks will be the parent ion contain? So look at here, this one is bromine 79 and this one is bromine 81. Okay, now they are found in approximate 1:1, so that's why its peak will be the same. Okay, in mass spectrometer. So when the peaks are the same, so there will be the two parent peaks. Okay, option A is the correct one. How many signals do you expect to see in the hydrogen NMR spectra of 2 bromopropane and 1 bromopropane? So here option A is the correct. Okay, use the same method which I have told you. Cations are produced from the sample matter in dash chamber of the mass spectrum. So option B is correct here. Okay, in ionization chamber the cations are produced. The magnet separates the ion on the basis of mass to charge ratio. Option C. The height of peaks of the mass spectrograph shows the abundance of isotope. Option B is the correct here. In the given mass spectrograph, which isotope has the smallest abundance? Now look at here, isotope neon 20 has 90% abundance, neon 22 has 8.82, and look at the neon 21 which has 0.26% abundance. So option B is the correct here.